Tired. Okay. I left you guys here. 18 root 54x squared over 6 root 6x. That's where I left you, right? And of course that answer is 3 root 9x, which is 9 root x. Right? Everybody's cool with a monomial denominator, yes? Even with variables in it. Going once. Going twice. Going thrice.
Yes.
Okay. So now we find ourselves at this spot. Now, we got to do a bit of talking about the nature of radicals right here. The first thing we have to know is radicals are used to show irrational numbers, yes? Right? But our goal should always be to simplify as much as we can to get rational numbers, right? Yeah. So, a rational number is x over y. Yeah? But there's some rules about x and y. They have to be what? Oops. X and y have to be integers. Right? So, knowing what you know about rational numbers, what can you say about what I'm about to write? Is that a rational number? Why not? Lauren? Because the square root of 3 isn't rational, it's living in the denominator. Okay, this is never allowed. Okay? And we get rid of it. Okay? We deal with it by multiplying by 1. What? If you multiply by 1, it doesn't change, does it? Of course not. That's why what I'm about to show you works. Because we're multiplying by 1, we're left with the exact same value. But if I multiply it by 1 over 1, does anything change? No, I'd have 7 over root 3. It doesn't help. But if I multiply it by root 3 over root 3, what do I get? That's 1. So the value doesn't change, does it? And what do I get in the numerator? 7 root 3 over what? No. Over 3. And that is okay. Don't ask me why. But math guys are perfectly happy with this, but they don't ever want to see this. Okay? This process is called rationalizing the denominator. And you always have to do so. Everybody cool? Now yes, Lauren.
For equals 7 square root 3 over 3, is it over 3 or is it over square root of 3?
It's over 3 because when you do square root of 3 times square root of 3, you technically get the square root of 9, which is 3. Okay. Cool? Okay, now, you guys are smart kids. it's real easy to see how this works with a monomial denominator, yes? But we know that monomials are only the first in a long line of nomials, yes? There's binomials, trinomials, and then polynomials, yes? So, we got to be aware of what to do when we have a binomial denominator. So, that is going to use this word called the conjugate. We use the conjugate to deal with binomial denominators. Okay? Now, before I go on, I have to make sure you guys are aware of something. What happens when I take x minus 3 and I multiply it by x plus 3? What happens there? Sam? Yeah, you double distribute. And what happens to the 3x and the 3x? They cancel each other out. And I end up with what? X squared minus 9, right? The middle term disappears, correct? This is the conjugate. That's why I've highlighted it in green. I had not an argument, but we had a dinner table discussion a couple of nights ago with the family. And because a couple of days ago, I was using the past participle of highlight. I was saying highlit. Yeah, that's why I highlit this green. My family has decided that it should be a highlighted situation. The past participle should be highlighted. So that's why I highlighted this in green, even though I did it in the past. But you wouldn't say I lighted the room. You would say I lit the room.
You lit the Christmas tree.
Yes. Huh? No, see, Byron, because looking up things on your phone or on Google is what is ruining conversation in the world. Because, see, we're still talking about it. We could end this conversation in 1 second with Google, and that would suck. Because I don't want to end a conversation. I like opening lines of communication. Which is why when you guys get older and you start going out to cocktail parties and to go get a beer with your buddies, when I turned 19 and went and got a beer with my buddies, the bar was where you talked to people. Now it's this. What was the name of that Indiana Jones movie? I don't remember. Temple of Doom. And it's over. But back in my day, you could spend all night talking about one scene in one movie because nobody could prove each other wrong. It was way better. But you guys...
After like a while, I get wanting to have a conversation, not going straight to the phone, but after a certain amount of time, you do want to figure out what the correct answer is so you can...
Really?
I get...
Do you think my day is made better if I actually know what the past participle of the verb to highlight is?
Well, yeah, because
I'm curious,
then I get intrigued.
and I want to know the answer.
Exactly.
And I do want to have a conversation about it, but after I don't know, an hour or two, if you're still talking about it, you want to know the answer. You can look it up and you should be able to use the actual...
Later. Yeah, but dictionaries don't have a lot of words like that in them. Highlight would probably be in there. Yes. Yes, I know. That bothers me. Anyway, so this is called the conjugate. What do you see is different between the conjugate and what I started with? Yeah, one's positive, one's negative. I switch the sign, right? Because if I switch that sign, I can make that middle term drop out, yes? So we all know that squaring gets rid of radicals, yes? So if I were to square this, I would have to do root 17 minus 3 root 14, right? Right? So 17 times 17. Oh, cool. That's 17. No problem. What's that? That's negative 3 root 17 times 14. Yes? And then what's this? Sorry, that's positive 3. Right? No, sorry. I was right the first time because we're doing the 17. It's negative, yeah? And then what's this one? Negative 3, 17 root 14, yes? And negative 3 is negative 6 root 17, 14. Did it get rid of the root if I squared it? I can't make that middle term drop out, can I? But if I square it with the conjugate, what will happen? I'll have root 17 plus 3 root 14. What is root 17 times root 17? It's 17, right? That's the trick, okay? Plus 3, 17, 14, minus 3, 17, 14. They disappear, don't they? And then what's the last one? What's negative 3 times positive 3? Negative 9. And what's root 14 times root 14? 14. 9 times 14 is 126, right? 17 minus 126 is negative 109. Did our radicals drop out? Everybody cool? So what's the conjugate here? What would I have to multiply this guy to tidy it up by? Because I'm not asking you to multiply it. I just want the conjugate. Root 34 minus 4 root 2. And then tricky, is there a conjugate there? The conjugate has to change the sign. Do I need to worry about it here? So is there a conjugate? No, because that one I just square. Everybody cool? Now the problem kids have with this is this one. 3 root 14 times 3 root 14. You've got to remember when you have x root y times x root y, you have to multiply both of them. So what's that answer going to be? It's going to be x squared, x times x, and what's going to happen with the y's? Y. Because square root of y times square root of y is y. Is everyone cool with that? That causes trouble. A lot of you are going to forget. Now let's do that with real numbers. 2 root 5 times 2 root 5 is what? 4 times 5, which is 20. Is everybody cool with that? Okay. So now, that's where I end grade 10. If you can rationalize the denominator of a binomial with binomial radicals, you're in business. Okay? That's where we're going to end grade 10. You'll go further with it in grade 11 or year 1, whichever path you choose next year. But that is as far as the year 1 teachers say they want you. Everybody cool? Yeah. All right, so let's do a little practice with that. Is this okay? No. Now, I'm going to give you a couple of things to make your lives easier. If you are uncomfortable with the... Is your hand up or...
No, I was stretching.
Okay.
Sorry.
That's what I was thinking. What exact part of you are you stretching there? Oh, you were doing this stretch. Yeah, I do that stretch too. I'm with you. Okay. I'm picking up what you're putting down. Yeah, but sometimes you do that tight one where you do your shoulders, but you keep your arms down. I get that one. I use that one.
I finished the stretch and I was kind of zoned out as well.
You just one arm.
Yeah.
That was another. Yeah, I know.
People do that. Oh well.
All right. So.
See, this is why you viewers from like wherever that lady's from.
Yeah.
Yeah.
So what do I do here? What bothers me here? The root of 7 is what bothers me, yes? Now, is there a plus or a minus in there? No. So I don't need to worry about a conjugate, do I? And since I only want to get rid of the root, would I be allowed to do that? Will that take care of the root? Right? I didn't need to worry about the coefficient, did I? So what happens when I multiply this? What do I get up top? 2 root 42. And what do I get on the bottom? This is tricky.
3 times 7.
Right, because this is 3 times 1, which is 3. Root 7 times root 7, which is 7, which gets me 2 root 42 over 21. Now, I chose this example on purpose because a great many of you, if you are not paying attention right now, are going to want to do what with this? You're going to tell me that's 2. Is it? No. This is done. Because this is 2 times 3 times 7. Any pairs? So it's done. What if this was simplifiable? What would we do? We would simplify it. Because when do we simplify? Always. Okay? No Amsherman.
No.
Interesting.
You just noticed now?
I don't know. Okay.
Are you just noticing now?
Well, I am due to the silence.
Oh, yes.
And I told a couple of jokes that everybody laughed at the first time, not a couple of minutes later. Now, to be fair, when Sam's not here, we have a bit of fun at Sam's expense. So we'll Amschumann up the scene today.
I still don't know what happened in that Luke one story.
I know. It's because I stopped recording on purpose, so it would stress you out.
Still don't know.
Okay. So, what do I got to multiply here? Just the root 6.
6. That's what I meant.
So what do I get
7
over 14 times 6, which is 84. Now look. What are you going to do there? Simplify. Why?
Because you
You can. 7 goes into 84, yes? How many times? 12. So what is this really?
Root 30 over 12.
Root 30 over 12. Is everybody cool? Now, stop for a second. I've left blank space here on purpose. Okay? Yes, Byron.
Okay, when you divide 7 by 84, how do you know where to put the 12? Maybe I'm just...
Okay, what? If I had 7 over 84, that's 1/12. What's the coefficient here? 1/12. Denominator. Cool? Okay. No, nothing wrong with that question. All right, so I need you guys to be aware of how this works. You're all understanding that 3 root 7 times root 7 is 3 times 7, yes? Okay. Now be aware that when we do the conjugate, this isn't going to work, is it? Because I got to make the 3 disappear too. So you got to still be able to understand that 3 root 7 times 3 root 7 is 9 times 7. Is everybody cool with that? Both of them are rationalized, right? Because it will both get rid of the radical sign. One of them we have to be aware of when we're using the conjugate. The other one we don't. Okay? Now, look at what would happen if we did this one fully. We'd have 2 root 6 over 3 root 7, and if I, not equals, you idiot, times 3 root 7 over 3 root 7. Then I would have 6 root 42, right? Over 3 times 3, which is 9 times m, which is 63, yes? Now, 6 and 63 will simplify, right? Because what goes into both of them? 3. How many times does 3 go into 6? Twice. How many times 3 go into 63? 21. And I end up with 2 root 42 over 21. And you see how I get the same answer. Okay? So if you are not comfortable remembering when you're allowed to only use the root, the radical, you can use both all the time if you want. It just requires an extra simplification. Well, hey, buddy.
Where have you been?
Everybody cool?
Yeah.
All right. So in C, oh yes, Lauren. Sorry, you're just too far past to see with my peripheral vision.
So, when you're doing the, like putting the root 7 over root 7 in,
Yep.
what would happen if you put root 6 in instead of root 7? Would you get the same answer? Or
If I did root 6 times root 6, or root 6 over root 6, I would end up with 2 times 6, which is 12, yes?
Yeah.
Over the square root of 42.
Yeah.
Now, square root of 42 doesn't simplify, right?
Yeah.
And I still have a radical in the denominator, which wouldn't be allowed, right?
Yeah.
But watch what can happen. What I'm about to do is just for educational purposes. Do not do this. Porpoises, yes. Now, if I were to go root 42 over root 42, right? I would have 12 root 42 over 42, correct? What goes into 12 and 42? 6. 2 root 42 over 7, right? Are they the same? Are they? No, they're not. Cool?
So why do you use the...
Because we are only caring about getting rid of the radical in the radical in the denominator. Okay? So this just won't work. All right, so what do we do for C?
Just kidding. We can do this.
What's wrong with root 18?
It's a root. It can be simplified.
It's a big number, isn't it?
Yeah.
So I say simplify every chance you get, yeah?
Yeah.
Okay, so if we don't, then what's our new denominator? It's 5 times 18, yes? Which is 90. No big deal. But this is big, yeah? So what should I do up there before I go any further? Simplify. What's that? 25 times 2. So what comes out? 5. 30 root 2. And what's that? 9 times 2. What comes out? 3. So I got 30 root 2 times 9 root 2, yeah? What's 30 times 9? What? Sorry, 3 root 2. 3 root 2. 3 root 2. Okay, 5 people are talking. 1. Go.
Okay, say the root denominator is really big, you can simplify...
Yes, you can. Absolutely. The reason I didn't here is just because 18 is a number I can kind of deal with. Okay? Now, up here, 9 times 2, what's coming out front? 3, right? 5 came out here. There was already a 6. So I got 30 root 2 times 3 root 2, yes? What's 30 times 3? 90. What's root 2 times root 2? 2, which gets me 180 over 90, which gets me 2. Is everybody cool? 18 is 3 root 2.
Oh, but what if we simplified the denominator?
I'm about to do that right now.
Okay.
Okay? Everybody cool? Now watch what happens if I simplify right away, which is what Sarah was asking about. I can make this right now 30 root 2, correct? Everybody see? Right? It'll show up in a second. And I can make this 15 root 2, can't I? Okay. What's 30 divided by 15? 2. Root 2 over root 2? No. 1. 2 times 1 is 2. Which way was easier? This one. Okay? I led you down the path of, I got to rationalize. And I said, you don't have to simplify all the time, so I could do this. Do you understand what I'm saying? So I could say now, but look what happens if we simplify first. Maybe it gets that easy. Everybody cool? You still need to know how to rationalize, but it might work out perfectly. So what are you going to do with D? You're going to simplify first? So what is 60? That's 4 and 15, yes? So what comes out? So it's 6 root 15, yes? Over what? 9 times 3. So what comes out? 3. What's already there? So it's 6 root 3. What happens to the 6's? Gone. Does that divide perfectly? To what? Root 5. Do I need to rationalize? No. See what I mean? Again, the point I'm trying to make here is don't learn a bunch of steps. Because if all you learn are the steps and you don't think about what you're doing, you're going to do a crap ton of work on this question, aren't you? You're going to be rationalizing, you're going to be simplifying, you're going to be worrying about coefficients, and you were able to do it all in your head if you simplified. Right? Everybody good? Everybody's good with monomials?
Yeah.
All right.
Great. That's good.
What happens here? I got a binomial on top, but the denominator is still a monomial. So how do I tidy it up? I rationalize the denominator by multiplying by what? Root 3 in the denominator. But if I don't put a root 3 up there, I change the value, don't I? Okay. Knowing what you know from multiplying, what do I do when I have a monomial out here and a binomial here? Distribute. That root 3 goes there. So what do I get? 6 root 6 minus 3 over 3. Now what? What do you notice? There and there. They simplify, right? What's 6 divided by 3? 2 root 6. 3 divided by 3? 1. Done.
But it's not, it's still 3.
No, because the 3 went into everything.
Yeah, okay, yeah.
Okay?
Because the root 6 is part of 6.
Mm-hmm.
Yeah.
You good?
Yeah, I see what you mean.
Okay. What's different in F? There's a coefficient, but it's still a monomial. Do I need to worry about it? No, so what can I multiply by? Root 2 over root 2. The 2 distributes. Now this is one of those situations. Would I simplify there now? Which is it, Sukmin? You're just saying them both. That's a time-honored traditional move in my class. Whenever I ask a yes-no question, all of you, yes, no, yes, no. And I just sit there like this. Of course you should simplify here because that is 4 root 3, isn't it?
Yeah.
So what's coming out? So I have 6 root 3 minus 4 root 3 over 2 root 2. Hey, wait a minute. 2 root 3 over 2 root 2. Now all of a sudden, what happens with the 2's?
They cancel each other.
They cancel out. And I'm down to root 3 over root 2. So now I only got to do root 2, and I get root 6 over 2. What's the mistake half you are going to make here in your practice? You're going to tell me that's root 3. Is it? No, because you can't divide radicals by regulars. Everybody cool?
Yeah.
Yes.
Again, look at the problem before you start going off like a maniac and scribbling all over your paper in ink because you all refuse to use pencil even though I ask you to. I know, Rose, many of you are finally learning, but I'm aiming that at the people that haven't learned and still insist on using ink. I'm aware that lots of teachers make you use pen, but every teacher you have ever had since Mrs. Bagcrumble in kindergarten has told you to do your math in pencil.
Yeah. Well, like
And what class is this?
but what if you get those pens that erase? Yeah, those are good.
Yeah, those are awesome, but I don't want you to have to go out and buy $5 pens because they're very expensive.
But good Christmas gift.
Everybody good?
Yeah.
All right, now let's take the gloves off.
And then it gets cold in your face.
Woo, doggy. What's the problem with G?
There's a binomial.
It's a binomial denominator. So I know I got to multiply by root 15 to get rid of the root 15. I know I got to multiply by the root 10 to get rid of the 10.
Plus,
But it's got to be addition. Why?
because then otherwise it's hard to do on try.
Because I want the middle term to drop out. This goes back to difference of squares factoring, yes? So what's up on top?
Distribution.
Now, stop for a moment. Just stop for a moment. Stop for a moment.
Stop.
I recommend here just writing 7 and 15 at first. And I'll tell you why in a moment. Plus root 7 and 10. I'll show you why in a sec. Over. Now what's happening down here? I'm technically doing FOIL. Do I need to write it out? No, because what do we know is going to happen? The middle term's going to drop out. So I know this is going to be 15 minus 10, yes? Okay. So I know the denominator is 5. Cool? Now, look closely here. Why did I leave it this way? Because it's already factored a little bit, yes?
Yeah.
15 is 3 and 5, correct? So I get 3, 5, and 7. Any pairs? No. So that is root 105. 7 and 10. 2, 5, and 7. Any pairs? No. So it's easy to simplify. If you actually multiply it out, and you're using big numbers, and you refuse to simplify at the beginning like I tell you to, then it becomes difficult, right? So I recommend that in this case. Also because it reinforces what we're actually doing, yeah? Okay, so what are we going to multiply h by? This is tricky.
Root 3 take away.
Why did I need the 2 here when I didn't use the 2 earlier?
Because it's now a binomial.
It's a binomial, and if I didn't have that 2 there, I would do 2 root 3 times root 3, which would give me 6, yes? But it wouldn't drop out, would it? Okay, Byron.
Yeah, for G, should you simplify the last part? Because
What last parts?
G, square root of 105 plus square root of 70, you can simplify those both. You can take 35 and 4 and 35 and, 35 and 3 and 35 and 2 and drag out the root. There's one number on the top.
No,
Because you can't add them because
they're not. That's not a pair of factors. This is 35 times 3, which is 5 times 7 times 3. Any pair?
Oh, okay, no.
This is 35 times 2, which is 5 times 7 times 2. Any pairs? So they don't simplify. Okay? If they did, of course we would simplify. Okay, so what's happening here? Oh, it's not equals. I do that all the time. It's times. What's my new denominator? I know that it's just going to be that times that minus that times that, right?
Yeah.
So I'm going to write it out longhand to reinforce for you guys. That is 2 times 2 root 3 times 3, yes? Minus root 4. Actually, I should have written root 2 times 2. But I have lots of time to talk about it while the computer decides to write what I wrote.
Oh, okay. I didn't know if you'd written it down.
Oh, I had written it down. We're just passing time.
Yeah, gotcha.
Oh, there we go. That should have been 2 times 2, yeah? And then it would have been 4 times 3, which is 12, minus 2, which means my final denominator is 10. Is everybody cool with the denominators?
Yeah.
Okay. Now the top, this is where it starts to get a little hairy because it's binomial now, isn't it? So let's go nice and slow. What's that? 6 root 6, right?
Yeah.
What's that? Right, minus 3 root 4. We're going to write it out longhand because we're practicing. What's that? Plus 2 root 9. And what's that? Minus root 6. Now, what do I do with that and that? Simplify it to what? 5 root 6. And what should I do with? It will be sexy and green in a second. In a second. In a second. In a few seconds. In a little while. Sooner or later.
There you go.
Where's the sexy green? Oh, there it is.
What do I do there?
You can simplify that.
That's minus 6 plus 6. Hey. What happens there? They're gone. 5 root 6. Now, am I done?
No. You can still simplify those two.
To what?
One.
Root 6 over 2. Is everybody Gouda?
Great.
The theory, not hard. The practice, not hard. The attention to detail, pain in the rear, right? So much to write down. And so easy to think, oh, I got this in my head, yes?
Yeah.
So easy. Everybody cool?
Yeah.
All right. I'm going to stop now. If you flip to the next couple of pages in your book, you see a few different assignments on radicals that cover everything. Now, I say they're an assignment, but then I gave you the answers, yes? Because the answers, this is pretty stressful because it's so technical, right?
Yeah.
So I'm not going to assign these to you guys. I wanted you to have the answers because it's stressful to try something that's this technical and not have the security blanket of the answers, right? So I'm cutting you a break here. It's called an assignment, but it's not really. But it's your homework, and it covers everything we've done with radicals. Add, subtract, multiply, divide, and simplify. Cool?
Yeah.
And we're going to take 2 days to do this. All right?
So what are the pages? Up to 137 or just 134?
In your books, it's going to be 134, 135, 136, and then 137 is just answers to 136. Okay? Everybody good? Now, just let me check. What's that one? Okay. Now, listen up. We're going to have one more set of notes that puts this entire unit together. Radicals, exponents, simplifying, everything. Okay? And that is page 140, 138 is where it starts. Okay? So we're going to finish up with radicals, and then we're going to circle back around to exponents, because by now you should have recognized that radicals and exponents go pretty close together, right? Because when I'm simplifying a radical, I'm using exponents, aren't I? Right? So we bring it all the way back around to where we started. And then we're going to finish this unit, test, and not accumulative, because this is the first unit after trig. Yeah? Yeah. Now, if I know you guys, and I think I do, you want these cumulatives marked.
Yeah.
So, hand them out. I don't care who to, it doesn't matter. We got to there. Yeah, we'll try it. We'll see what happens. The worst thing that could happen is you give a kid 1 mark too much or 1 mark too little, which will affect their final grade by 0.3%. Right? Just throw them on desks, Leighton. Seriously, just drop them. It doesn't matter. There you go. Normally I would never do this, but I'm tired of hearing people complain about their privacy and then yell their marks out as soon as they get their tests back. It drives me up the wall. I don't want anybody to know what I got. What'd you get? 7 out of 10.
Oh, God.
All right. No, just don't. Just mark it. Fine.
No, but now you can just do it as literally as possible.
On the front, write marked by whomever you are. And then when you get your test back, you can go find your marker and you can yell at them the way you yell at me. So then you can all feel how it feels to be yelled at and argued for 0.5 of a mark that is going to make 0.001% of difference at the end of the year. Yeah, it will, because I round my marks off to 0.001s, don't I?
0.001s add up.
They do. If you get 500 0.001s, you'll get 0.5 of a percent.
Yo.
Word.
That's if you round it up.
Where's he going?
I don't have 500 assignments. All right, listen up. Listen up. 13 and 14 are just out of 2 marks. Okay? Wait a sec. 13. Wait a minute. Just let me double check. What did we say that the trig section was worth? Said it was worth 15. Just let me double check. 1, 2, 3, 5, 7, 10, 15. Yeah, they're worth 2 marks each. Because these two are only 2 marks each because they're SOHCAHTOA. No matter how much SOHCAHTOA you got to do, you only got to know 1 skill. So, I'm going to do the work. You look at what's written in front of you. You decide what proportion out of 2 they got right. All right? Now listen to me. What? What?
Yeah, we haven't marked 5 yet.
Horse pucky.
No.
Oh, yeah, we didn't. Okay, go back number 5. Yeah, we marked 9. Okay. Now, guys, listen, please. Listen, please. In order to do number 5, you had to do one of 2 things. It's out of 3 marks. You decide how much they get. You had to either take 290 miles, convert it to km, convert it to meters, convert it to centimeters, and then divide by 54. Or you had to take 54 centimeters, convert it to meters, convert it to kilometers, convert it to miles, and then work with 290. Okay? I don't care which way you do, but your answer was something in the neighborhood of 875,000, I believe. Okay? So, if they have 875,000-ish, and they have done one of these conversions, they've either converted miles to metric or metric to imperial. Okay. Give them a mark. Okay? Not yet. We're not done. Give them a mark out of 3. Okay? Now, if they missed a step and they have a missing, they say it's like 86,400, then they've missed one of these conversions. That's 2 out of 3 because they only missed the decimal place. If they're way off, they missed the conversion twice, or they multiplied when they should have divided, that would be 1 out of 3. If they did no attempt at a conversion, they did something with 290 and 54, nothing.
It would take 3 steps.
Yes. Don't worry, I'm sure some people wrote that. I'm hoping they didn't, but I'm sure I would get some interesting answers.
If in a parallel universe.
Okay, my first answer for that question was like 15, and then I was like, hey, that's not right. So
Good for you.
You never think about it, like 290 miles.
I know that. I have given that question approximately 1,000 times. And no matter how many times I make fun of it, because that's my go-to question in that unit, isn't it? The answer has to make sense, right? Okay, here, it's out of 2. I am going to do the quickest way to solve this. Right?
Right.
Theta equals 74. Adjacent equals 7. I need the height of the cliff, which is right there. Which is what? Opposite. What uses O and A? Tan 74 equals x over 7. So x is 7 tan 74. But that's not the height of the cliff. Plus 1.68. If they don't add that, they get 1 out of 2. If they use tan, they get their 1. If they remembered to add 1.68, they get their 2. If they did anything with sine and cos and didn't eventually come back to tan, because some kids in the other class used sine and cos to find the hypotenuse, and then they did Pythagoras to find this. And I was like, well, I guess it's right. 2 out of 2. Maybe.
yeah, so if you did do that, is it right?
Yes.
Because I put that on my
Your answer is 21.5, I believe.
No, it's 26.6.
Oh, 26.09, right. 26.1, yeah. That's fine. The other class never had sine law as an option. Yeah.
Exactly what I did.
Did you do trigonometry?
Yes.
Did you get 26.1?
Yes.
Then you have 2 out of 2. Stop.
Good job. What if they just guess out of all the numbers they give?
Ann and Byron. Yep, Byron's measuring that cliff. He needs this side, yes?
Well, they said he's this side. Look at this.
That side is x. you have this angle. So if you know the hypotenuse or across the river, you can get that, yes? What's the only one you can find with your info now? Across the river. So you had to use trig on this blue triangle. And that's a hypotenuse. Now some of you crazy kids may actually have used sine law. And that's okay. I don't know why you would, because they're 90-degree triangles, but that's cool. So for the blue triangle, it's 35 over sine 36. Yes? Because I needed the hypotenuse. Cos 36. That got you the blue. And then in the red, you had tan 68 equaled x opposite over 35 over cos 36. And your answer was something like 107. Again, if they use sine or cos law, but still got 107, you give them the full 2 marks. Because this is a trig test. And sine and cos law are trig.
Whoa! So it's out of 2.
Out of 2.
I don't like how they drew this. Negative 3 marks.
Alright. 3 marks. Did you have to draw the Cartesian plane to do this question? No, because that's an x and that's a y. And you know sine is y over hypotenuse, cos is x over hypotenuse, and tan is y over x. You could have done it algebraically. I don't care. I always draw it because you guys like to see these things. Negative 5, 8 is out here, yes? So that's negative 5, that's 8. So this must be the square root of 25 plus 64, which is 89, right?
Yeah.
So now you know that sine equals 8 over root 89. Cos equals negative 5 over root 89. Tan equals 8 over negative 5. That's all you needed for the 3 marks. If you wanted to go crazy, not crazy, but if you wanted to do it algebraically, then all you got to remember is those are your x's and y's. So the h is always the square root of x squared plus y squared, which is 25 plus 64, which is root 89. And all that stuff was in your notes, both versions. All right, now we separate the people from the people. All right.
This was oh man.
The hiker has a starting point.
Yeah.
Right there. Point A, that's camp. Once he starts walking, I need a compass, yes?
Yeah.
So the compass, I'm going to put in red, dotted red. Where is 320?
And
0, 90, 180, 270. Where's 320? It's out here.
yeah.
How far did he walk? 850. Now, if that's 320, what's this part? 50. Right? Now, once he's walked 850K, 850 meters, so 850K take a long time, he'd still be walking, and we still wouldn't even be able to do this question. What happens at 850K? He stops and changes direction. So what do I need to do at every change of direction? A new compass.
I did that first and then I changed.
Oh, I did that.
And he takes off at 225.
Yeah.
Well, this is 180. This is 270. Where's 225? Right down
There.
until he is directly west of his original camp. There's original camp. There's directly west.
Yeah.
Now, if this is 50, what's this?
That's 40. Yeah, 40.
This is 50, because angles. So this part of it is 40, yes? This part of it is from 180 to 225, which is how far? 45. So if this side is 45 and this side's 40, what's this?
85.
85. I want to know how far he is from camp.
Yeah.
If that's 50 and that's 85, what's that?
That's 40. 45.
45. Right?
Not quite. He's 5 more.
Right?
Yeah, he's 40.
What would be a right angle?
45, 90, and 40 is 130 and 50. That's their angles. Now, what do I have right there?
You have a pair.
I have a pair. Which, soon as I have a pair, what do I do?
Sine.
Sine law. So, I have sine of what?
45.
Don't even ask me.
Just stop. Sine of 45 over what?
850.
850 has to equal sine of what?
85.
85 over what?
X.
X. 850 sine 85 divided by sine 45 equals your answer, which is
1.2.
Okay.
1,197.5.
1.2 km. Oh, to the nearest tenth. Yeah, 1.2. Now, listen to me. Listen to me. There is no... That's not really true. It would be really difficult to figure this out in many other ways. You could have used... Your person could have done a 90-degree triangle with 50 and 40, and then 45 and 45, and then added the two. That's okay. Did they do trig?
Yeah.
Yes. Did they get the answer? Yes. Did they draw a good triangle? Yes. Did the person walk northwest and then southwest? All that stuff has to come into play. Right? Give them a mark. No. Give them a mark out of 5. Don't ask for yourself. Don't ask what you think you wrote and what you think you should get. You are trying to mark a paper. Put a mark on it out of 5. Now I will answer questions. You first.
Okay, I know you're going to probably yell at me, but if they literally just drew a triangle and nothing else, is that still a mark?
Is it this triangle?
It's a triangle.
Does it go up and left and down and left?
Yeah, it does.
Then they get 1.
So,
Just, I don't care. Give them 5. What?
if they drew a triangle and did sine law, even if the question is still wrong and they used sine law correctly, but if they drew a triangle and did sine law,
2. Nothing.
oh, Okay, so then that's a 1. Because they're triangles.
No.
You do a triangle, that's one.
Now, listen to me, please. Listen to me, please.
Sine law.
The first 3 pages up to the pyramid question are Unit 1. Give them a score on the front out of 15. The trig stuff, give them a score out of 15. Add it up, give it back to the person, and then you can look it over, and you can all start screaming to get your extra marks from me.
Oh man, I know I was wrong in this one, but I was kind of mad at
And it
myself.
was the one question
I
that
know.
I was sure that I got.
That's the stuff. That's what I'm talking about.
But you know, I guess 20 out of 30 is acceptable. I'll have to learn to live with myself.
Have a look at it, bring it up.
Thank you.
I'm happy to see better trig scores.
I'm gonna take the
I wasn't sure how to mark the last question.
I got it.
So I wanted to ask you.
No. No. How can there be 320 degrees in a triangle?
Okay, so just 0.
That's Sarah. Yeah.
Wow, a lot of trig marks are going up. Tick, 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 boom. Lots of trig marks are going up. Lots of trig marks are going up. Oh, and some trig marks are staying the same.
If we did way worse, we'll have to have that, right? Like, just burn it and never look at it again.
What'd you get?
Oh, for shame.
I passed on half of it. It's okay. Don't worry. Overall, I passed. I passed too. I'm so proud of myself.
I'm really hoping that we're trying to do more than that. We all have our own lives.
Now, ladies and gentlemen, the reason I did this is to let you see how actually difficult it is to assign you grades on these questions. All right? The reason I would never make you mark a real test is because real tests count. Somebody explain it to Byron so I don't have to take that ruler and dig out my eye. Oh.
But if it's very important that you mark this higher, then
Which is why, ladies and gentlemen, and all other of the 57 possible combinations and permutations, that is why I only did this here, okay? I did not do it with an actual test because actual grades are nobody's business but your own, even though you all immediately yell every grade you get every time. Okay? Now, once again, listen, please. Once again, I will remind you that you have even one more chance to improve this mark. When do you think that would be? On your final exam, which will be broken to sections. So let us pretend that your final exam, for argument's sake, there are 8 units Your final exam has 10 questions on each unit. Just say, right? There'll be 10 trig questions. If you get 9 out of 10, that's 90, and you got 9 out of 15 on this, which was better than your actual trig score. 9 out of 15 on this is, well, let's say it's 10 out of 15 to keep it 2/3 easy. 66.7%, yes? 67%. And you got 9 out of 10 in your final. What am I going to do to your Unit 2 mark in January? Change it to 90%. Okay? What?
So we'll be doing one of your exams and that numerical is...
No.
Oh.
You will maybe do that numeracy thing. I don't know. That numeracy thing means nothing to me. I don't care about it. It means absolutely nothing to me. Because all of you should be learning numeracy through math. I will never, ever, ever give you even a practice test on that. Because you should know how to do that already. Do you understand me? That is the problem with the FSAs. Teachers got so angry and up in arms about it, they had the nerve to say, these tests aren't fair, and then they would still prepare their kids for it. If you really thought those tests didn't matter, then you should just give them to the kids, because they are assessing their ability to read, write, and do math. Right? And yet, every teacher that I know of spent a goodly amount of time preparing for the FSAs. Something that they said they didn't care about. I don't understand that. I don't care about that numeracy thing. It couldn't matter less than to me. Because all of you should be able to pass it. Because you all have good numeracy skills. If you didn't, you wouldn't be here. Right? I don't know. Because I am not a member of the Ministry of Education. Thank goodness. Because if I was, boy howdy, would you guys have a different experience at school. What's the next question?
School rocks.
Sam.
I was gonna say, is the exam score like the final score and you take that over? Like, what if you
There will be a final score in check my mark out of blah, 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 blah. And that is worth 20% of your grade. End of discussion. But each section gives you one more chance to tidy up any units that you are poopy on.
Yeah, so I was going to ask, like, because if you get a better mark unit on the exam, then it'll bump up your mark. Or if you get a worse mark.
What happens with the cumulatives when you get a worse mark? Somebody explain it to Sam so I don't dig my eye out with a ruler. The total mark of your final will count. Totals of cumulatives don't. But the total of your final will. Is that what you were asking? Okay, because that was a very roundabout way to get to that question. Thousands!
Whoa!
I don't know. Here, I'll see the future. Tomorrow's lottery day. I got my numbers. I won't be here Tuesday. I don't know, Sam. Okay? Because I don't. All right? I saw at least one other hand. Was the question answered in one of those two discussions with Kayla or Sam? All right. Now, once again, I am looking at these when they are handed in. I know there are some of you that are still down. I am not an idiot. I can read body language and expressions. Believe it or not, I am okay at social cues. Those people have yet another chance between now and January, right? I know that as the very high achieving members of this grade that you are going to obsess about your 67% in trig and not say, I got 100% on measurement. You're going to throw that out the window and you're going to obsess about this one unit. Even if all your other units are in the 90s, you're going to go 8 over this. I know you because I do. How are you going to fix this problem? You're going to sit down and you're going to look at your trig. because you know that everything else you kick its ass. Do you understand me? If you are one of the people that on your second crack at trig, you're still a little, bleh, you don't need to worry because you got lots of time, and you got to remember, if you had $100 and I took away 10, can you still go buy a lot of taquitos?
That's a good way to spend money.
Do you understand what I am saying? If you had $1 million and I took away 100,000, would you still be a rich person? Yes. Doing poorly on one unit does not do any of the following. It does not define you as a math student. It does not define you as a person. It does not make you bad at this course. It does not make it so you shouldn't continue in IB. It does not make it so you should feel bad about yourself. It does not make it so you should feel that I or somebody else would feel bad about you. Do you all understand? Your lives are infinitely more varied, rich, and diverse than one grade. And yet you guys get hung up on this one grade. Okay? Don't. Because if I thought that you didn't belong here, you wouldn't be here. Okay? You all belong here. You all belong in this class with the best and brightest math minds in our school. And you're all here because you impressed your last year's teacher. Over half of it was me. So anyone that was in my class last year, you deserve to be here. I wouldn't have let you be here if I didn't. Okay? All right. You have a couple of pages to do for Tuesday. Right? You've got the answers. It's gonna be hard. Okay? If the question goes from A to E, you might, no problem with A, try E. Because what I gave you, these questions are wicked, wicked hard. Some of them. The whole point of it is you got to start swinging for the fences, right? You've had grade 2 to grade 9 of the same crap. We got to straighten it out now, yeah? All right. Does that mean if you're having trouble with it on this assignment that you're bad at it? No, because it's your first try at it. Okay? Okay. You're still going to get a review, and we still got a few more lessons on it. You still got an X block. You still got lunches. You still got after schools. Save your bacon, even though none of you need it, because you're all brilliant. Okay? Okay. Work. I will give these back to you probably Tuesday after I've gone through the math and check who's going up, who's going down, and who's staying the same. Okay? That's crazy talk. That's correct. So you got another 3 marks coming to you, I think. I think it was out of 3. 1, 2, 3, 4, 7, 10, 12, 3. Yep. So you got, oh, look at you. Let's just fix that up right there. Up top.
What if I was never given?
I do that. 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 I do that.
That one.